Neutron stars and pulsars are fascinating and extreme objects found in the universe. They are both remnants of massive stars that have undergone supernova explosions. Neutron stars are incredibly dense objects, formed when a massive star exhausts its nuclear fuel and undergoes a supernova explosion. So, in this video, we are going to talk about neutron stars and pulsars, the universe's extreme objects. The video is going to be amazing, so make sure you stick to the end. During the explosion, the outer layers of the star are expelled into space, leaving behind a dense core composed almost entirely of neutrons. Neutron stars are so dense that a sugar cube-sized amount of neutron star material would weigh as much as a mountain. Typically, neutron stars have a mass between about 1.1 to 2 times that of our Sun, concentrated in a sphere only about 10 to 20 kilometers, about 6 to 12 miles in diameter. Neutron stars are incredibly dense. Their matter is so tightly packed that a single teaspoon of neutron star material would weigh about 1 billion tons on Earth. Neutron stars can rotate very rapidly, often completing hundreds of rotations per second. This fast rotation is a result of the conservation of angular momentum during their formation. A pulsar is a type of neutron star that emits beams of electromagnetic radiation out of its magnetic poles. These beams are not perfectly aligned with the star's rotation axis. So, as the star rotates, the beams sweep through space, much like a lighthouse beam. When these beams point towards Earth, we observe a regular series of pulses of radiation, hence the name pulsar. The emission from pulsars is usually observed in the form of radio waves, but they can also emit X-rays and gamma rays. Pulsars are highly regular in their rotation, making them incredibly precise natural clocks. Some pulsars can maintain their rotation rate with an accuracy of 1 part in 10 to 15, rivaling the most accurate atomic clocks on Earth. Pulsars were first discovered in 1967 by astronomer Jocelyn Bell Burnell and Anthony Hewish, who observed regular radio pulses from an unknown source in the sky. This discovery was initially referred to as LGM, Little Green Men, because of its mysterious nature before it was determined to be a natural phenomenon. NASA estimates that there are as many as 1 billion neutron stars in our Milky Way galaxy. The majority of neutron stars discovered thus far are young neutron stars that sweep energetic radiation over the Earth as they rotate at incredible speeds. Older neutron stars that have had billions of years to slow their spin and cool are less conspicuous, but are no less fascinating. With neutron stars, we're seeing a combination of strong gravity, powerful magnetic and electric fields, and high velocities. They are laboratories for extreme physics and conditions that we cannot reproduce here on Earth. Large Area Telescope Science Team member David Thompson of NASA's Goddard Space Flight Center said in a NASA statement, "Before we move on, support us by hitting subscribe and the bell icon to get notified when we post new videos." Now, let's get back to our topic. Supernova remnants are the remnants of massive stars that have undergone a spectacular explosion known as a supernova. These cosmic events are among the most energetic and cataclysmic occurrences in the universe. The supernova explosion expels the outer layers of the star into space at incredible velocities, typically reaching thousands of kilometers per second. These ejected materials, along with the energy released during the explosion, create a shock wave that propagates outward into the interstellar medium. Supernova remnants are one of the primary sources of high-energy cosmic rays in the galaxy. These cosmic rays are energetic particles that travel at nearly the speed of light and impact Earth's atmosphere, influencing our planet's atmosphere and space weather. Depending on the mass of the progenitor star, the supernova explosion can leave behind a dense core known as a neutron star, or, in more massive cases, results in the formation of a black hole. As technology advances, astronomers continue to harness innovative instruments to probe deeper into the mysteries of neutron stars. One of the intriguing questions scientists seek to answer is the internal structure of neutron stars. While we know they are primarily composed of neutrons, the precise arrangement of these particles remain a subject of ongoing research. The study of neutron star interiors involve complex theoretical models and considerations of nuclear physics under extreme conditions. The quest to understand the neutron star equation of state is crucial to unraveling the nature of matter under such extreme gravitational forces. Additionally, neutron stars also play a crucial role in the universe's chemical enrichment. During their violent supernova origins, these massive stars synthesize heavy elements through nucleosynthesis, scattering them into space. These elements, crucial for the formation of planets and life as we know it, owe their existence to the dramatic life cycle of stars, including neutron stars. Furthermore, neutron star mergers are a focus of intense interest among astrophysicists. When two neutron stars collide, they create a cataclysmic event known as a kilonova. These mergers are believed to be the source of heavy elements like gold, platinum, and uranium, and their study provides vital insights into the universe's chemical evolution. Moreover, the detection of gravitational waves from neutron star mergers has opened up a new era in astronomy. Gravitational wave observatories such as LIGO and Virgo allow scientists to detect ripples in space-time caused by the violent collisions of neutron stars. These observations not only provide a new way to study these enigmatic objects, but also offer a deeper understanding of gravity and the fabric of the cosmos. To consider how dramatic and violent the near-complete gravitational collapse that births a neutron star is, one only has to look at the material that it creates and the dimensions of the object it comprises. Imagine the sun reduced in size until it is a sphere that sits comfortably within the city of New York, which is 35 miles wide. Being reduced from a diameter of 870,000 miles to just 12 miles would have a striking effect on the material within it. And this is definitely the case for neutron stars. NASA estimates that a single sugar cube comprised of this neutron-rich matter would weigh around 1 trillion kilograms if it were brought to Earth. That's a sugar cube that weighs as much as 3,000 Empire State Buildings or the entire human race. This makes neutron star matter the densest material we can see in the universe, according to Swinburne Center of Astrophysics and Supercomputing. And this has another effect. As a consequence, the gravity of neutron stars is so strong that NASA Goddard Flight Center says if a marshmallow were dropped to the surface of one of these exotic stellar remnants, it would accelerate so quickly that when it struck the surface, it would release energy equivalent to the detonation of 1,000 hydrogen bombs. While marshmallows don't tend to rain on neutron stars, gas stripped from companion stars in binary partnerships with these extreme stellar remnants often does. When this gas hits the neutron star surface at speeds as great as millions of miles an hour, it creates powerful firework displays in X-ray light that flicker in intensity thousands of times per second or perhaps burst only once every few years. The density and gravity of neutron stars isn't the only thing that makes them the most exotic objects in the universe. They also have some other extreme characteristics. As we gaze into the heavens, we find that neutron stars and pulsars, with their extreme characteristics and cosmic influence, continue to ignite our curiosity and challenge our understanding of the universe. The more we learn about these fascinating objects, the more we appreciate the sheer complexity and diversity of the cosmos we inhabit. With each new revelation, we move closer to unraveling the profound mysteries that lie at the heart of neutron stars, shedding light on the very fabric of our existence in this vast and wondrous universe. So, that's it. Please like, share, and comment your thoughts below if you liked this video. Remember to subscribe to see our next video. Stay safe, and we'll be back soon with another video.